Bismillahirrahmanirrahim. Michelson Morley experiment, dawn of modern physics and relativity. This experiment was carried out for the existence of ether. It was believed that the ether is the source of propagation of light. This experiment was done in 1887. This is the apparatus, diagram of the apparatus. The light source through the light to the splitter. This is splitter of the beam. This splitter split this light into two parts. One goes perpendicular to this mirror, and the half goes to this mirror, and half transmit toward the parallel mirror, this one. They reflect back and combine over here, and here is the detector. It tells us that either both of the beam reach at the same time, or there is a time difference reaching these rays to this splitter. So that is the apparatus. Light throw from the source to the splitter. It split in two parts. One moves perpendicular to the path and the other moves parallel to the path, and they reflected back from the mirrors and join over here, and this is the detector that tells us that the light beam that reflected from both the mirror reach this point at the same time, or there is a difference of the time. Now this apparatus is placed on the surface of the earth, and the earth is moving with velocity v, which is 30 km per second. So this apparatus is actually moving in the ether. If there is ether on the surface of the earth, then this apparatus is in fact moving in the ether with velocity v, which is the velocity of the earth. So that is the schematic diagram of the Michelson-Morley experiment. It is placed somewhere in the lab, but the earth's surface is moving. That is why it should move through the ether, and the ether velocity would be the velocity of the earth. So let do the mathematical calculation. Okay, this is the you see the parallel beam take this time. You see here is let's say the beam splitter. It moves this way to the mirror. This is the splitter. So the velocity of ether is opposite the velocity of light, and in coming back toward the splitter, both the velocity added. So in this case the velocity is c plus v is added over here, and it is subtracted over here, c minus v. So on this path, which is from the splitter to the mirror, both of the velocity is added, and when it is reflected back toward the splitter, the velocity is subtracted. Okay, so this is, you see, this is the time taken when it is moving from the mirror toward the splitter, and this is time taken by the light ray when it is moving toward the mirror. If it is moving toward the mirror, this is the time taken by the light, and this is coming back from the mirror to the splitter. When we add them, we get this value. Okay, now the perpendicular case, when the splitter send half toward the mirror, so in fact this will not move this way, it will move that way. In this direction, because the apparatus is moving in the splitter. So the splitter is moving in their direction, and we need this value, this perpendicular value. So this perpendicular value, this is the speed of light, and here is velocity v. So this perpendicular is c square minus v square under the root. So that is the perpendicular velocity from the splitter to the mirror, and it come back with the same velocity because we need this one. So if I complete this triangle again, so this will be v and that will be c. So again we need this perpendicular. So in both the cases, the perpendicular velocity to the path of the beam is c square minus v square. So the time taken, this is in fact the parallel time taken. So and the perpendicular time taken is 2 times L over this velocity, the perpendicular velocity, that is c square minus v square under the root. And I think we calculated, we written it in on the next slide. So this is the time taken by the light when it moves parallel to the path of the motion and parallel to, in fact, the velocity of the ether. And this is time taken by the beam moving perpendicular to the path of the beam or the velocity of the ether. Okay, so we have to calculate the difference between these two times. So you see, this is, I write it in this slide. Okay, so the difference is t parallel minus t perpendicular, that is the difference in time. So that is equal to 2 CL over V, C square minus V square minus L over, this is same L. Okay, so let's write it capital L. I write it, this is capital L over C square minus V square under the root. So using the binomial theorem over here, let me simplify a little bit. This is 2CL over C square taken common, 1 minus V square over C square, and the other is 2L. C is common, so it is 1 minus V square over C square 1 by 2. So now we can write it 2L over C, and using the binomial theorem we have this 1 plus V square over C square and minus 2L over C. This is 1 minus V square plus V square over 2C square. Simplifying it, we get you see the first term will cancel out, and the second will be so we left with L and V square over C cube. So that is the time difference which will be recorded by the detector. So we calculated it on this page, and you see this is LV square over C square. Okay, this is the time difference which should be recorded by the detector. Okay, when the apparatus is rotated, by 90 angle, rotation by 90 degree of the apparatus, we get this delta T, which I name dash, is equal to negative of this value. This is minus L V square over C cube. So magnitude of both of the time is same. So the total time, I am writing the total time, total delta T is the sum of these two, because we need their magnitude. So this is 2L V square over C cube. Okay, so this is the total time by the beam. This is total time difference of the beams between two paths. One is perpendicular and one is parallel, and when the apparatus is rotated, so the apparatus is rotated during the experiment, and we get that this is the total time difference which should be recorded by the detector. So the V is the velocity of L in this case is taken 11 meter. V is the velocity of the earth, which is 3×10⁴ meter per second, and c is the speed of light. C is equal to the speed of light, which is 3×10⁸ meter per second. Okay, now this is the time difference, but we are interested in difference of fringes. How many fringes difference occurs? So we need delta S. Delta S is the distance difference. That should be C time delta T total. So when we multiply this with C, we get 2L V square over C square. This is the total path difference. This is the total path difference of the beam when it moves perpendicular to the path of the light, the beam, and parallel to the path of the beam. So this is the total length difference. And then fringes is defined, this distance be divided by total fringes difference. That should be delta S, change in the path difference over lambda, where lambda is the wavelength of light. So this formula become 2L V square over lambda in C square. So this will be the fringes difference. So the wavelength of light is taken to be 5 multiply 10 minus 7 meter. Putting these value in this formula, that is the fringes difference, we get 0.44 value. So this is, you see, velocity square cancel their dimension, length square cancel their dimension. So this is purely a number, 0.44 fringes difference. So this is the expected fringes difference. Mathematics tell us that this should be the fringes difference. But when the experiment is done, the experiment was carried out, so the observable fringes difference, is 0.01 fringes. So the percentage of this observable and this mathematical prediction, so the percentage of F observed by Michelson Morley over the theoretical fringes difference is 0.01 over 0.44, which is about multiply over 100, by 100, and this is 2.5%. So This is the result of the Michelson-Morley experiment. You see, it is negligible percentage. That is why this experiment tells us that there is no ether. The ether, for the presence of ether, this percentage must be about 60 to 70%. But this is 2.5%, which is very small percentage between the observable and predicted value. So this experiment proves that there is no ether, which is the medium of light. So the ether concept is washed out after this experiment. So this is null result. Observation is 0.01 and the prediction is 0.44, so no significant fringes shift. Ether theory was challenged, and this experiment support the speed, the first postulate of the special relativity, which says that the speed of light is constant for all inertial reference frames. This is a cornerstone experiment in modern physics and support